Welcome to Git as Game Logic, what video games can teach us about version control. Naturally, I have to ask, do we have any video game enjoyers? Based on last night's event, I know we definitely do. Perfect. So this is going to be great for us then. So before I get started, I just want to talk a little bit about myself, of course. No, I'm just kidding. Just tell you a little bit about who I am. So my name is Bree. I am a front-end software engineer turned developer advocate at HubSpot. And I also create technical content online. So between front-end development and technical content creation, what I really like to do is teach programming concepts, which is how we got to a talk like this, where we're going to be talking about Git in terms of video games. Something that was really challenging for me when I was starting computer science or learning how to code was really understanding some of the more niche coding concepts. And something that helped me was taking them out of the realm of coding and applying them to something that I'm interested in or know a little bit more about. So that's what I like to do, to show people that there's not one right way to be or to become an engineer. And of course, naturally, I have to say that I love video games. So how many of us feel comfortable with Git? Show of hands. Okay, that's a lot of hands. How many of us feel comfortable and then maybe we start to panic a little bit once we've committed to the wrong branch, or maybe we've deleted our work on accident? That's mostly me most of the time, and a lot of us as well. And last question, at least for now, how many of us actually go to the Git documentation itself first when we have problems? One hand? As expected, not a lot of us, because I know that I personally don't. I think a lot of times we are comfortable with the basic Git workflows, like cloning a repo or creating our commits or pushing to a remote. And we can check out branches, but for a lot of us, it kind of just stops there. We get comfortable with what Git can do for us in terms of best case scenarios. But as we know, best case scenarios are not the norm when it comes to version control. So what happens when we actually start to work on a team of developers, when there's a ton of code that's being committed, or when we are working with even more branches than we can think about? There are bound to be merge conflicts because we are all human. And with version control, merge conflicts or mistakes can mean overwriting your teammates' code, exposing secrets, or completely removing code if you're not careful. And we know that those can all be very costly mistakes, both in time and expenses sometimes. So this is where Git can really start to feel like it's hard. And it's not because we're not good developers. It's because Git's user experience isn't always the most intuitive to us. So we're going to walk through Git today, not like a terminal tutorial, but more with something that we are familiar with. Even if you've only played video games very casually, there are a lot of parallels between video games and version control that you can make yourself. So whether you are still on a journey of becoming a little bit more familiar with Git, or whether you are a seasoned Git pro, my hope for you today is not to walk away with a full tutorial of Git commands, but more so a different mental model or way of thinking about Git that maybe you can use yourself or even pass on to more junior developers who are getting comfortable with this technology. So before we get into, or while we're getting into version control, we're going to start it by what it looks like to pick up the game for the first time, to defeating the final boss. But before we can dive all the way into our game, we need to start with the tutorial. So y'all said y'all like video games, and I would love to hear what any of y'all are playing. You can just call it out. Fortnite. Fortnite, okay. What else? Factorio. What was that? Factorio. Oh, I've never heard of that one. Okay. Really? Has it gotten better? Okay, I heard there was a lot of glitches and a lot of bugs and stuff when it first came. Oh, okay, good. Well, I personally really love Zelda. That's my favorite franchise, and I am just counting down the days until we get another game like Tears of the Kingdom, personally. I really love that it's open world. I could go into that forever, but that's not why we're here today. But one thing I really loved about the game itself was actually the tutorial section. It was confined enough to not make me feel overwhelmed, but it was large enough to give me scope and scale of what could actually be done in the game. And when we talk about Git, that's exactly where we're going to start. So the tutorial zone for Git, let's start with version control. And before I get too far into it, I just want to make sure that we're all on the same baseline of what version control is. So version control is basically a system that tracks and manages the changes to your code. Your code is constantly changing and it's constantly evolving. And without a reliable way to track those changes, or to undo or collaborate when things happen, your code is going to break very, very quickly. So Git is one free open source resource that we can use in software development to track those changes in our code. So we've entered our world of Git, and the world of what we can accomplish is very vast, but just starting out, we want to establish good practices and consistent routines. So let's start with where we are actually going to get our baseline and what that looks like. Before we get started, we have to have a slate to start with. Sometimes that is going to be a blank slate, and we'll use things like git init to initialize a repo. Or maybe we're going to be starting with a friend's save, if you will, and we're going to be copying a full repository using git clone. Now, this is also going to include the entire commit history on their machine, or on your machine. So it's really like copying and pasting their save onto your computer. This is really where we get started, and this is our title screen. This is the place where we start a new instance, or we can dive into a game that has already been started and has a little bit on it. Once we have a place to start and a slate to put our code, this is where we can actually do the fun part for most of us, which is the coding. So we're going to make additions, deletions, and eventually we're going to get to a point where we want to save or persist those changes. We need to actively decide what items we want to add to our pack and equip our gear, because you never play a game for a long time without having anything equipped on you at all. And the same is true for Git. We wouldn't want to show up to a checkpoint without any gear. So for this, we are going to prepare, and we're going to use git add to stage all of the changes or select changes from our set of changes and files that we've made. So in Git, something that's really important before we get too much further is how our code exists in Git itself. So there are 3 stages or states that your code can exist in. The first one is going to be the working directory. The second is going to be the staging area or the index. And the third is going to be your actual committed history. Now, git add is going to move those changes from your working directory to the staging area. But git commit, which is the next one that we're going to talk about, is going to take your changes the next step and actually save them in a permanent snapshot in your project's history. So once we have our gear set and our files staged, now it's time to start marching on to that actual checkpoint itself. So when we're ready to store and save our progress that we've made in our game, this is likely going to be notated maybe by a character that you're playing as or how long you've been playing the game. But with Git, it's going to be notated by a timestamp and a unique ID for the files that we've saved and what specifically we've committed. If you're anything like me, you save in multiple different slots just to make sure, in case you ever have to go back to a different save, you have the ability to do so. And the same is basically true for Git. Every single one of our saves or one of our commits has its own unique ID so that we can go specifically back to that ID if we need to. So now we've committed our progress and we've been explicit about the changes that we want to make. Now we need to make sure that other people can see the changes that we intend to make, because changing the code does no good if we are only going to keep it on our machine. So when playing a game online with friends, the only way to do this really is to be in a constant state of syncing and pulling data so that you can see the changes that they're making in their world and they can see the changes that you're making in your world. So for us with Git, this looks like uploading our code to a shared remote through a service like GitHub or GitLab or Bitbucket. And for many of us, this is where the cycle ends. This is our second nature, what we do every single day, and it kind of stops. So what happens when we're ready to step out of that tutorial zone and explore a world of multiplayer? Or maybe we can think about it as playing with our teammates and colleagues. So once we're no longer playing solo and everything changes, this is where we are playing, going from playing single player to multiplayer, and other people's choices actively affect our game. So if everyone modified the same files in the environment, you can already imagine that everything would be utter and absolute chaos. And that's where branching comes in. So this gives every developer their own lane or their own space to do things like test new ideas, fix bugs, or test features, all without touching that main story. So in Git branch creates a new pointer to a current commit, essentially giving you a duplicate save of whatever is in your main environment so that you can start there and start testing safely. Now, when switching to a branch, or you can think about it as changing your focus, this is done with Git checkout. It updates your working directory and your index to reflect the state of your current branch. Now, technically speaking, Git rewrites what's on your disk to match the files from that branch. And then you can think of it like shifting roles. Maybe if you're a full stack developer, you can think of it like going from front end to back end. And everything in your workspace is going to reflect the world of whatever is in that branch. Now, when we think of keeping track of things that are in that branch, Git uses head. Now, head is a symbolic reference to your current branch itself, and it's the one that's going to be receiving the commits. Now, when we move branches, head also moves as well, but when you check out a specific commit instead of an actual branch itself, that's where head has the potential to become detached. You can look around, you can make changes, and you can even test bug fixes, but if you don't create a new branch, your work won't actually be saved. And that's like basically editing a backup file without making a real copy. It's just kind of out there in space. Now, of course, while you're doing this and you're working in your own branch on your own little island, your colleagues and coworkers are making their own changes as well. And these updates are being referenced on our remote server. And in order to stay in line and aligned with what our colleagues are doing, we need to sync everything up. So we can use things like git pull, which combines two actions. The first one is going to be git fetch to receive the changes. And the second one is going to be git merge to actually merge those changes into our local code or our local branch. So this ensures that you are working with the most up-to-date version of the project, just like downloading a patch before you're going to log into a shared world of a video game. And when it comes to your work being ready to be integrated back into the main, that's where we talk about git merge again, but this time in a little bit of a different light. This time, you are going to be merging your changes into the remote repository. And what Git does is it calculates the common ancestor and attempts to merge them. Now, if there's no changes that overlap, everything is good. We love it. Everything goes through just fine. But if two or more people have made changes to the same files or the same lines of code, that's where we get into our favorite things as developers, which are merge conflicts. Who remembers their first merge conflict? Did you panic or did you freak out just a little bit? I did panic and I did freak out. I love this meme that's please let me merge first, because this is exactly how I was. Do you know how you're on a highway and you're supposed to zipper, like when you're getting on the highway off of a ramp, where maybe one person's supposed to go, then another person, very coordinated, very slow activity. I was the person who was basically driving all the way to the front because I assumed if I merged my code first, that was going to handle all of my problems. But we know in reality it does not work that way, and if you try to make it work that way, your teammates will not like you very much. But I eventually realized that merge conflicts aren't something necessarily to fear, but they're something that we just have to have a little bit of patience with and help Git understand what we need to keep and what can go or what changes need to be made. So once the merge conflicts are completed and you've decided what can stay and what can go, the merge completes and your branch history reflects both sets of changes. So we have navigated parallel tracks, we have integrated different timelines, and we have reconciled decisions. Now, what happens when things actually go wrong? Whether it's a bug, or whether it's a bad merge, or maybe a file has mysteriously disappeared. Welcome to the part of the game where something broke, or at least that's how it feels. And let's talk about how Git handles failure and how it gives you tools to recover from that failure when things tend to go off the rails. So, every developer has that moment, like we just talked about. Something breaks, panic sets in, and you are not exactly sure how to undo the damage. This is our Git boss fight. Not because it's punishing, again, not because we're bad developers, but because the stakes feel very high. So imagine that you're working on something and then all of a sudden you need to change direction or pull the latest from main. Your working directory isn't clean, and committing your half-baked code would honestly just make things a little bit messier. We have a tool called Git Stash that takes your modifications, both staged and unstaged, and it tucks them away temporarily. Now, under the hood, this is basically just creating a different commit object on a separate track so that you can reapply them later. It's basically like tossing something in your inventory or your storage chest before you dive into a new quest. But what if things start to get really cluttered or you just want a clean slate? Have you ever been playing a video game where you didn't realize when you started that your actions are going to impact the ending, and then you want to go back to the beginning so you can make different decisions and get a different ending? That happens to me a lot because I like narrative-based games. But in general, what do you do when you want to go back to a previous save of some sort? This is where Git Reset comes in, and it actually has 3 different versions that you can use. So for Git Reset, you can use Git Reset Soft, which is basically going to move the head back to the previous commit and keep all of your stage changes. We have a mixed mode, and then we also have Git Reset, Reset Hard, which is basically undoing the entirety of your changes. So this basically gives you the option to decide whether you want a full clean slate and start your game all over again, or whether you just want to go back to the previous chapter. And when you're making these changes to files or something has gone wrong and you're debugging, there's going to come a moment where you need a few more answers. Your question might be, who made this change and when did it happen? And git blame is going to be what annotates each file in the commit and when it was last modified. So I know it says git blame, but it's not technically about assigning blame. This is more about tracing history and helping you understand what the story is behind the code and why it changed and when. This is going to be your passive investigation. This is like the game commentary track that you can read through and determine how each character has contributed to the story itself or what they contributed. Now, there is going to come another time where maybe you want to know where something has changed, and your question isn't necessarily it's not why, it's where. This is going to activate your detective mission with git bisect. So with this, you give Git a good known commit and a bad known commit, and it uses binary search in order to narrow down the exact commit where the issue was introduced. So you can also automate this with git bisect run, and then you can give it a script for faster debugging. But this, unlike git blame, is going to be your active investigation, where you are narrowing down suspects through testing. Ooh, talking is hard. So you can think of this almost like doing a cross-investigation if you've ever played a detective video game like Phoenix Wright. So all of these tools that we've talked about in this section rely on those 3 states of where your code lives in Git that we talked about a little bit earlier. That's going to be your working directory, where you are currently editing, your staging area, where you plan to commit, and also your repository, which is where your work is actually being committed to. And the key to figuring out how to recover is really understanding where those changes currently live and how to undo or how to fix something without losing all of your progress. So the next time something breaks, just remember that we have to choose the right command for the job. Recovery in Git is about understanding the tools itself rather than trying to avoid mistakes entirely. And once you do, it becomes less intimidating to figure out how you need to resolve your problems. Now, after every boss fight, you evolve. Maybe you get a new object or a new skill that you can use. And basically, this unlocks features that gain access to high commands like rewriting history or maybe customizing your system. And you get full control over the game's inner workings. So now we are headed to the end game. So we've survived the tutorial zone, we've navigated through multiplayer, and we've beat our Git boss. Now we're in the end game. And this is where Git is really going to start to feel like a system to shape your workflow itself and not as something that you have to fight. So we're going to talk about rewriting time, enhancing our tools, and working smarter, not harder. But Before we do, I just want to say these are really tools that I wish I would have known a little bit more about in my first software engineering job. And the thing is, like most of us, I like to have really nice, really clean commits. I think that's what we all strive to do. And it was not always like that for me. I'll say this because we're friends now, of course. I did not always used to have the cleanest Git workflow. So my Git workflow used to be working on my own island, almost in isolation, and I hated having to pull my changes from main because it was always going to be updating my changes, and I felt like I couldn't be as productive. So what I used to end up doing was working on my own little silo, and then when I was ready to have my changes saved, I would commit that branch. But I would then create another branch with the actual changes in main, pull that, and manually copy and paste my changes into that new branch. Now, that sounds crazy, saying that out loud all these years later, because we know that's not how you're supposed to do it, and it takes a lot of time. But the thing is, what I didn't realize is, number one, there's code constantly being committed while I'm doing this. So that means there's also extra time being spent that I'm going to have to go through and update my branches. And it was a nasty cycle that was basically just happening over and over again. Now, I think I fell into this trap because I was fighting the tools that Git was giving me, and I didn't really understand how they were supposed to work versus just forcing my own workflow onto them. And I think some of us fall into this trap, maybe not as crazy of a one that I had, but I think eventually, like when we're starting, we're getting used to Git. Some of us don't have the best Git habits, and that's totally okay, and it's usually because we don't fully understand those tools. So let's talk about one really intimidating tool that I stayed away from for a long time, which is Git rebase. Has anybody played Ocarina of Time, the Zelda game? Perfect, perfect. So you know there's time travel involved, which is how we are able to win the game eventually. Now, we can think about Git rebase almost like rewriting a character's timeline. Unlike Git merge, which is going to create a merge commit and preserve our branching history, Git rebase rewinds the story and lets you apply changes on top of a brand new base, which creates a more linear and cleaner sequence of events. This is going to be great for not only your coworkers to understand what changed, especially if you get into a couple of ugly commits that you didn't mean to do, but it's also going to be great for future you. Now, let's say that you don't want to merge an entire feature, you just want to merge one cool ability or one feature that your teammate has built. That's where we get into things like Git cherry pick. So cherry pick is going to allow you to pluck a specific commit from one branch and apply it to another. So this is like importing one enchanted item, or let's say a master sword, or whatever the item is, from one quest of the game and adding it to your quest that you're currently working on. And in the end game, we still have mistakes that can happen, again, because we're human, and it happens. But now we have the power of time travel again, but differently this time with reflog. So with Git log, we can see the visible history, but reflog is basically our hidden journal. So this is tracking every single move that our head has made, even those that you thought were lost to resets or force pushes. You can reference it using the head at end notation that I have here. And it basically is going to restore those previous states, which is really good when you accidentally reset something, or maybe you've overwritten something that you didn't mean to. And when you have the same merge conflict for the third time, I don't know why that's moving like that. I didn't even add any animations. Sorry if that's distracting. But when you hit the same merge conflict for the third time this week, now we can have something called git re. Now, this is basically, it's called reuse recorded resolution. That's hard, by the way. And this basically works as a smart function that allows you to apply the same resolution on top of a merge conflict. Now, I will say I don't use this one too often because there's not a lot of times where I have this same exact merge conflict that arises, but I can totally see instances where this would be useful. And just like any good role-playing game, once you get to the point in the game when you're like, okay, I need to switch things up. I want something that's a little bit new. That's where we get into Git hooks. So these basically allow you to create customizable scripts for Git. And we can think about these things as our linters before committing, or our test runners before pushing, or maybe doing things like Slack notifications after your code is merged. This is where Git really starts to feel less like just a tool and more like a personalized addition to your workflow. So let's take a deep breath, because that was a lot of Git commands that I just went through. Out of curiosity, did anybody pick up either a new command or a new way of thinking that they might apply to their workflow? Yeah, good. That was the whole point. I love it. So we've come a long way since our title screen. And Git originally, back either earlier today or even when we first started, may have felt like a complicated punishing system with too many rules, but by now we've unlocked some new abilities or maybe different ways of just thinking about them, and we've learned how to recover from failure. And we've also gained control of our project's timeline, which is no small feat. Now, these tools don't just make us better at Git, they actually make us a more confident developer, because here's the thing. A lot of times when we learn Git commands, it's in reaction to our environment. Something breaks, we panic, and we fix it, and we learn in crisis mode. So this talk wasn't about memorizing every single Git command, because there's so many that are in the docs that are not here, but it's more so about creating a mental model for how we can think about things moving forward. So Git is a reactive tool by nature, and when we learn and understand how it works, we shift from reacting to mistakes to proactively shaping our workflow. And this confidence that we're building is a tool that's going to help us anticipate, it's going to help us debug smarter, and help us collaborate more effectively. So you're not just a player anymore. You're a developer who understands how the game engine works itself. And so the next time something goes wrong, you're not going to just work through it. You're actually going to survive and thrive through it, now that you know what tools to reach for. So thank you so much. I really enjoyed this talk, and I hope that even a different mental model or way of thinking was super helpful. I would love to connect. I have all my socials, LinkedIn, all the places where I am online, and would love to chat, everything like that. Thank you.
Thank you, Bree.
Thank you.
Now, if you've got a question for Bree, there is an opportunity, but I'm going to ask the gents to start preparing for dangerous demos, because we've got a stage shift going on here. And we'll also be doing a drawing. Oh, whoops, sorry. We'll also be doing a drawing for some programming socks. Yeah, very exciting. But let's see. Any questions for Bree here? Are you seeing anybody, Bree?
I don't. That's okay. It was a lot.
Oh,
it was a lot
yeah,
of
Jack. Jack never lets us down. Good old Jack. I've got a mic to run to Jack. Here we go. Thanks, Jack.
Okay, so Bree, are you also doing GitOps things?
No.
Oh, I was going to say, what game maps to GitOps?
What game maps? Oh, you know what? I'm going to have to think about it. I leave the GitOps to the very professional infra people on my teams.
Okay, anyway, very interesting. My challenge of the day is automating going from my Git instance to automatically updating my continuous integration, continuous delivery stream. Mm-hmm. So your stuff is right on topic for me. Thank you.
Perfect. You're welcome. Thank you.
Thank you, Jack. Thank you, Bree.
Thank you.
Any further questions for Bree here? In that case, let's give her one more big ClueCon thank you.
Thank you, everyone.